10 seconds. We could talk amongst ourselves. I could tell you some more about myself. Oh, I'm good to start. Okay. Like I said, I'm going to dumb it right down because I come from a background of teaching small children, and what my kind of crusade is to get more people into electronics and the sort of technology industries, because as children, they're not encouraged so much because teachers are, to be frank, a bit scared of it. So explaining electronics to the uninitiated, it was my kind of like idea that I was going to do. So I do make stupid things as well, mostly out of cardboard because I'm skint. So if you have a look at Tanya Fish Makes on WordPress, told you I've been awake too long, then there's all my stuff on there. I'm on Twitter as Tanarai, and you could email me at work if you really have to. Well, anyway, some people prefer emails. So I started off at Pimoroni, having run away from teaching, going, I do not want to do this anymore. And I started just putting Pybos in packaging, and it was the most soothing thing I have ever done. It was amazing. But gradually, they let me play with the lasers, and that was fun. And so I learned a bit about the lasers, and then I thought, well, I didn't really know what this electronics did. So I started trying to explain it to others so that I could learn what the electronics did in the first place. So I ended up back around at teaching, even though I'd run away screaming in the first place. So about a year ago, I started off doing something for the Barclays Eagle Lab, which was a kind of initiative in the UK. Don't know if you have it here. Probably not. No, blank faces. Okay, you don't have it here. But yeah, basically it's like a kind of like, let's get more people into tech. Here is some funding from banks. That's it, basically. And so I took along some lights, and I got people to make rainbows with the lights. And that went quite well. So then we got the cardboard out, and we made them into like things that lit up made of cardboard. Because that was my particular skill there. I go to various events and just play with like all sorts of like Pimoroni stuff that I drag along and force people to use. But cardboard, again. But yeah, I sort of fell into doing more stuff, and then boss man went away for a business trip, and the new Pi came out, and the Pybo didn't fit. And he kind of designed the start of it, and then it didn't quite fit, so it got altered 17 more times because I'm not very good at rapid prototyping. It's more like painful prototyping for me. But then eventually, I don't know if you know the Pybo. It's a case for the Raspberry Pi. It comes in all different colors, and it's made of Perspex. Cut on lasers! Sorry, not cardboard. So yeah, then I got onto more stuff, which was more explaining things, and as you can see, my beautiful finger prodding some sweets there, because I wanted to see if you could make sweets electronic. You can, which is fine. And I started relating it to things that kids like. So kids like sweets. So if you can involve sweets in your circuits, it's brilliant. Sorry, candy. If you can involve candy in your circuits, it's brilliant. I can speak the lingo and everything. So yeah. I explained mostly, sorry, I'm that tired. I mostly explained because, like I said, I didn't really know what was going on. So it let me do a load of research, and I kept going and prodding people and going, why does it do that? Why does it do this? How does it do that? Why is this happening? And it kind of helped. It also helped the teachers that I talked to as well, because that's from like a massive survey of UK teachers where they were like, well, we don't teach it because it's too difficult. And they just skip it? Yeah. Oh, design and technology. It's where the UK curriculum stuffs electronics, but they put it as an option. So you can do graphical design or electronics. And guess which one most teachers choose? So as people in tech, what we can do from the point of view of bringing things into education and getting more and more kids interested in it is supporting and doing good documentation. Your documentation is probably brilliant, but when you look at it with a pair of eyes that doesn't recognize all the technical terms, it kind of goes. So glossaries, lots of glossaries are wonderful. And that removes the fear because you're not looking at a whole different language. We are What are we doing? Haha, I will let you have a go at the dingbat. Oh, okay, it has a ripple as it slowly works its way back. Okay, we're assuming. See? No, okay. I thought it was too late for me. So we're assuming that people know what we're talking about. We're just starting from our level of knowledge and trying to explain it from there, and we're not actually going back to basic principles. So we tend to use metaphors as well, which introduces a whole new world of complications. So what's the bucket doing? What is the bucket? The bucket is this thing, and then this is this thing, and then this happens to the bucket, but what actually happens in the circuit? And it becomes a whole nother level of flannel. Do you have that word here? And bump, gibberish, extra information that you didn't really want. Yes. Flannel. Now you've learnt something today. Okay, so new words is the problem. Background, we don't give enough background. And also tick boxes. Sometimes we go, do you know that? Yep, great, and move on. And forget that we might need to revisit it. So I did an experiment on my Twitter. I asked people to explain how that worked, but with one limitation. You know XKCD? You know the upgoer 5. The upgoer 5 uses the 1,000 most common words in the English language to describe anything. So I figured if you can't describe it in the 1,000 most common words, then it's probably not a simple explanation. People tried to cheat. But this was my favorite. It's a poem. You get a bit of poetry as well. Poetry reading. With legs in place, the light clear and bright, the power moves round from left to right. Low to high, high to low, take away the legs, the light will go. All credit to Kerry Truman there, because she wrote it, not me. But yeah, I quite liked it that people were trying to challenge their ways of explaining by keeping it very simple to one tweet with only those simple words. I quite like this one too. I'll let you read it rather than me read it out, because I just need to rest my voice for a minute. So what do you think of that explanation as electricians or electronic device type people? Is it simple? Is it straightforward? Are you going, no, there's a glaring error in there? Can you write a better one? Hop on Twitter, put it on the post. Also, pictures really help when you're trying to explain things. Too many people try and go, and there's this force over here, and it's the force is pushing this over here or pulling that over there, and you can't see it. So kids go, How many times have you had a circuit out or something, and someone will come across and go, can I touch it? Will I get electrocuted? Because they don't know where the electricity is. They don't know how it can travel. They don't know what it's going to come through, whether it's going to zap them or whatever. But this was me trying to explain conductive pads. Capacitive touch, that's the word. Sorry, like I said, wide awake. Sorry, I keep laughing into the microphone as well, and it makes all these funny noises. So yeah, pictures are good, but what's better than pictures? Moving pictures. Go on. Oh, it does it on mine. Don't do it on yours. That's a GIF on mine. Well, anyway, on the GIF, this magical arrow comes in one side, and it says, negatively charged, and points at these, and then I change those to positive and negative, and you can see them move to one side, and then swap them over, and you can see them move to the other side. This was me trying to explain how e-ink works, which I'm not allowed to say e-ink, because apparently that's a brand name, electronic ink. You know what I mean anyway. Kindle stuff. Am I doing all right for time? Do I need to hop off or? No, you're doing great. How long have I got? Like an hour and a half. I need to sleep. I really need to sleep. So yeah, another great way of getting kids involved and getting the next generation interested in electronics is just to give them some and just go, here you are, here's a battery, here are some LEDs, see how many you can light up with that. Why does it only work one way round? It doesn't work that way. It doesn't. Don't tell them anything to start with. Just answer their questions. Tinkering is brilliant. Once they've got the hang of lighting up a light bulb, get them to make some crafts around it. Kids love crafts. Crafts and candy is the golden goal there. But, and googly eyes. Googly eyes are brilliant for everything. So yeah, just get them into simple ways of doing things. You can follow this even if you can't read the words. I hope. So yeah, tinkering. Tinkering does help people to question things. And it starts you out on that road of not being told how things work and trying to memorize it and regurgitating it. You're actually learning about, why does this work? Let me try this out, see if it works. If it doesn't work, why doesn't it work? Can you show me why this doesn't work? Can you show me how to fix this? And then you're guiding them, but not telling them. This says insert picture here. I could just draw you one. I gave kids, you know the concept of squishy circuits? It's conductive. Play-Doh is conductive, but you can make Play-Doh with sugar that's not conductive, so you can use it to make circuits with, and then you can jam LEDs into it. You can get some 9-volt batteries with wires on the end and jam them in as well, and kids love it because it's messy. But they have no concept when you first give them the Play-Doh and stuff of how it should work. So they just keep experimenting until it does work. And then they start telling each other. They're like, oh, no, that won't work because it goes straight through the Play-Doh there. And they're actually getting the concept of a short circuit by their own experimentation. And so as long as you start going, oh, yeah, that's called a short circuit, then they've got the vocabulary there from something that they've already learned. Yay. But yeah, there should be some nice pictures of some horrendously odd-looking creatures that they made, but yeah, key is let it go wrong, because that's how they learn. So I'm afraid it's not an hour and a half. I am done. I am going to go to sleep now.